I'm Jason Bergeron. I'm the equipment product manager for Argen. I've been in the dental industry for about 13 years in various aspects of CAD/CAM, 3D printing, 3D scanning, based out of Boston, Massachusetts, and manage our equipment support team as well.
I am Evan Katz. I work for Argen Canada, based in Toronto. I'm the senior education manager, and I do a fair bit of product development. I am an RDT, specializing in implant work in Crown and Bridge for many years ago. I have managed multiple dental laboratories in both the US and Canada. And some of my roles have included keeping Mailbox updated for our customers, as well as training customers throughout North America on both the Roland Mill and Mailbox.
So we've got a pretty packed agenda, and I know we started a little bit late, so we're going to try to get through this and get everybody informed here. So please, if you have any questions, save them to the end, and we'll either handle it out here or out in the back. But we're going to talk about some simple things, just some key terms in case some people have different knowledge bases here. Then we'll go into some shortcuts, some simple and advanced workflow items, and then what's in the Roland Standard Edition, and some important aspects about PC hardware and some things that are happening in the future for the Mailbox software for Argen.
Yeah.
And so a little bit about Argen, DG Shape, Mailbox. It's kind of been a collaboration of everything. So Roland, or DG Shape, has been working with Mailbox exclusively for the last few years, originally called Easy Shape on their wet mills, and then started updating some 3D and going into their dry mills. Argen first started working with Roland mills and the Mailbox software up in our Canadian office first, and have recently released it here into the United States over the last couple of years, and have been developing that kind of partnership between Roland, Mailbox, and Argen. Yeah. Do you want to talk a little bit about Argen Canada?
Sure. So Argen started working with Roland in 2012 with the introduction of the Roland DWX50. The original CAM software that came with that was from 3Shape Cambridge. I don't know if anybody ever had a chance to work with that. It's great for simple Crown and Bridge, but it had a lot of limitations. And one of the big issues with 3Shape Cambridge was that the support and general understanding at the time of CAM was an issue, both from our perspective as well as from 3Shape's perspective. In 2015, Argen started to work with SimSystem with the introduction of Some 3D, and we basically started to slowly transition customers who were running Cambridge onto Some 3D. And in 2017, Argen moved the majority of their users over to the Mailbox platform.
Okay. So Mailbox, there's been a few iterations of Mailbox, but there is a misconception out there that Mailbox will not work with some of the older mills, and that's not accurate. It will depend on who your reseller is and the support that they have, but the Mailbox product will work with any of the dry or wet mills from Roland, as well as other milling systems from other providers as well.
So we're going to go through just a couple key terms so that we have a full understanding of what we're talking about as we get further into the presentation. So the first key terms that we're going to talk about are strategy and monostrategy. So strategy from a large general overview is basically just a template for milling operations for a single restoration type. What Some 3D and both Mailbox use is a monostrategy. So it is a strategy that is purpose-built, and it has the ability to adapt to whatever restoration type you're using. So the best way to look at it is it's a very, very long strategy with a lot of multiple operations. And based on what you pick as you're going through Mailbox, it then sorts everything out to make the strategy for that specific operation, for that specific material and that specific object type. And what we have found, most importantly with the monostrategy, is that it is predictable. The second thing that we want to make sure that we understand here is the difference between a 5+2 indexed and 5-axis continuous. So there's a little bit of a misconception that when you're talking about the Roland mill and you're talking about a Mailbox or some 3D strategy, and it says 3+2, that you're using a 3-axis portion of the mill, and then when you pick 5-axis, that's when you're using the 5-axis aspect of it. That is in fact not true at all. The 3+2 is still a 5-axis operation. What the 3+2 3 plus 2 indexed does is it gets into its XYZ or XYZ position, and it basically locks it there, and then it gets into its AB position, and it locks it there. So when it's milling, you'll have the milling tool coming down, but the actual disc in the adapter or in the clamp will be still. Whereas with the 5-axis continuous, the A, the B, and the X, Y, and Z axes are all moving at the same time. Equator line or height of contour. This is not available in some 3D, but in Millbox, you can see that when you start putting your sprues, you get this line here. And this line is not necessarily the height of the contour of the crown. It's the height of the contour of the crown when it's placed in Millbox in the most ideal angle. Another term that we'll be using today is called a part border offset. And the part border offset is a number that is going to tell you the distance between the outside wall of the restoration and the inside portion of the stock or the zirconia or whatever material you're milling. What we like called a object type or type selection or type cell. These are all of the different types of materials, the different types of objects that we can mill. And so the monostrategy incorporates all of these, and then based on what you're picking, it will then disseminate into a list. So for instance, the difference between a coping and a full contour crown is the coping is not going to give you the option of a 0.3 millimeter anatomical tool, whereas the full contour will. Shortcuts. So shortcuts allow the end user to nest more efficiently, which is the whole purpose of this talk. What we're trying to do is let's do more stuff quicker. Okay, that's what we're trying to promote here. Shortcuts will also allow you to see potential issues prior to milling so that you can change whatever you need to within Millbox to avoid having these errors. So the first shortcut that we're going to talk about here is the Control E, which is going to show and hide the clamp. So it's just a short video here, and in this situation, all we're doing is hitting Control E to hide and show the clamp. The next shortcut is Control U, and that's just going to show and hide the undercuts. Okay. Some users like to see these undercuts because it helps them place the sprues in a proper position, and some users don't like to see these undercuts as well at all. So it just allows the end user to pick and choose what they're looking for. 9 and 0. So if you, in a situation like this, if you click the 9 button or the 9 key, what it'll do is it'll turn the restoration transparent, and you'll be able to see through it. And then to get it back into its solid state, you'd basically push the 0. This will help you, especially with implant work, to make sure that you have your whole milling curves and all your margin curves in the right position. Control R. So we're going to get into the red caps a little bit later into the presentation. But by pressing Control R, what that's going to do. Sorry. No, it's the one before.
Oh, we went back.
Oh, sorry.
Or we went forward.
There we go.
There we go.
If you, when you click Control R, what that's going to do is it's going to remove the visualization of the red cap. And lastly, as far as shortcuts, we're going to talk about the Control D, which is going to open up your material configuration file. And what this is going to do over here, it basically just opens up all the materials that are within Millbox. Some of them are customized toward Argen. Some of them are just generic files. And this is just showing you here that you can kind of come in here like this, and you can actually sort them based on producer or material name or material code.
All right. So another area inside the Control D material configuration is going to be your block types. And we get a lot of requests for users that want to customize their material list. Some vendors put in their private labels, or you bought a disk that is of different size that isn't in your software. So a key way of making sure that your portfolio is filled up is here. Is you can go into Control D, go into the block area here in this little upper right-hand side, And you're going to get a list here of all the different material types and their sizes available. And so right here we can see that there isn't a 25 millimeter selection for PMMA. And so if you get a PMMA disc that's that size, all you need to do here is go ahead and select one of the PMMA material disc sizes that are there, and then hit copy. When you hit copy, it's going to create a duplicate of that exact size. And then when you come in here to edit it, all you got to do is change here, change it to the correct size that you're looking for. And you can do this with PMMA, wax, zirconias, any of those composite materials. And you can also customize the naming and any of these fields here to make sure that you get the exact materials that you're using in your laboratory. After you've created your copy of your material, it's going to show up here on the bottom. And just to make it easier when you're selecting your materials from your drop-downs when you're doing your jobs here, all you got to do is just drag it right up and put it in line with the rest of your materials, and then click Save. And that's it. And you'll be able to then have a customized material list that fits your needs and your laboratory's branding. Also, here's just a quick slide for anyone that wants to take some pictures, or it's available right on SimSystem's website as well, of all the shortcuts that we've talked about so far.
Okay, so before we get into the advanced workflow, we're just going to do a real quick talk about our simple workflow, which is the easiest way to nest a case, which is going from new job to import the STL, put that STL into a blank, start the mill, and if you want to, you can take a look at your simulation. So this is an example of again, a very quick way how a lot of laboratories are nesting their cases. So you're picking the mill, you're picking the material, you're picking the fixture. It's going to go into a folder. You're going to figure out which crown you're looking for. You're going to pick the object type. You're going to select that that's what you're looking for, and it will nest it. It'll tell you what size of disk you need. You're going to go pick it out.
Always remember to change the scale factor to match the material that you're using.
And there we go. And at this point, you can go ahead and you can save the toolpath and you can start milling this out. And this is what happens in a lot of laboratories. And you have all of these options over here to figure out what exactly you're looking to for strategy options. And that's what we would just call a simple workflow. It's just click, 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 click.
So the simple workflow is fast and easy, but there's also ways to even optimize that with some advanced features here. And we're going to get into the configuration button here. And to get there, we need to get into one of the admin areas, and so that we can customize it to fit our workflows here. And you also need to know what you change can affect how your software interacts with you. And a lot of these can be set up so you can still use the simple workflow, but it will make your customized settings work. And the way you get in there is we're going to hit Control-Alt and 7, and it's going to ask you for a password. And why doesn't it actually have the password there? 1,000, right? Or no?
No, it's enable.
Oh, it's just enable. Oh, it is there. There we go. Password's enable. When you do that, this icon here is going to show up in the bottom right-hand corner. In 2019, this icon will already be there, but you'll have limited options. Basically, you can change the language. Now when we go in there, we're going to see a whole list of other options. So we also just have here, we have some general settings. So this is where, how your job files are being stored, where they're being stored, where your STL files are coming from. We have options for language, stabilizers. If any of you are doing full arch bridge work and you notice there's a lot of options for stabilizers and you have a specific one that you always use, you can limit that, so it's only showing you that option. We've got some cavity fit options. We've got strategy options there, sprue selection options here. All these things can be customized to make your workflows just work faster. So in our example here, we saw that this was the mono strategy for Argen's tooling. And this is the default option that was done in the simple workflow. If you know that you only ever do 3+2 finishing and you don't want to use the internal 5-axis, or you want to default the 0.3 millimeter dB always turned on, those are things that you can customize within the advanced options here. So for that, we would hit the we'd Control-Alt-7, hit the password enable, and get in here and click on strategies. And from there, we have some options, because we can change different options for different mills. Once you select the mill, you can then select the type of material or the soft or hard material, just to make it generic. And then you have all these default options. And if I hit the next button, here we go, make it a little bit bigger so everyone can see. So this is all the options that are down there. If it's got a check mark, that's going to be your default selected option. If it's got the visible, it means it's actually visible for you to interact with. So if you have a 52D or a DCI and you never use the cleaning brush and you're tired of clicking it off or clicking it on or turning it on, you can disable that here. And that just makes your simple workflows a little bit better.
Okay, this is the video.
Is this the video? Yeah, there we go. So we're just going to show a video here of how to go in, make any changes to adjust the workflow. I think this is for zirconia. So you're scrolling down the list of available options, and we're going to change some of them here. So by clicking on the little eyeball, it makes it so that option disappears from the main list. And by changing the check mark, it makes sure that that becomes the new default. So we can see that this was our default, and we went in and just made a few changes, and now we have these extra options that are set by default for us. So even if you're doing this simple workflow, you now have customized it to fit your lab's needs. You can also change it based on an object type. So if you have certain indications that you want to use specific strategy options on, you can customize it for full contour crowns, full contour bridges, copings, anything like that. So we see here we've got some options when we're dealing with just full contour crowns. We're just going to use 3+2 indexed, and we're going to have the brush tool, and we're going to use the 0.6 internally. But for bridges, we want to have more options to manage some of those undercut areas. And we're going to say we're going to always do the 0.6 interproximally as well, because we want to make sure that we get those embrasures opened. Another area that a lot of customers are looking into is how to adjust the way the sprues come in. A lot of customers, especially in older versions of some 3D or even Millbox, the default comes in at 3, and they don't know that you can modify how many sprues come in on your object types. So they're always sitting there either deleting them all, adding them all in. They always make maybe partially cuttable. So they have to delete them all and then change them all to be partially cuttable. It's a lot of wasted time adjusting sprues. Well, in that same area, we can then modify where the sprues are placed, how many are being placed, and what kind of sprues that are being used. So the next thing you're going to do is you're going to come into the same advanced area, and then you're going to click on the sprue button down here. And here we have the default option, which is use some 3D pin insertion mode, which basically means it's going to add 3 sprues to your object type, all about 120 degrees rotationally around it, so it gets that triangle formation. And if you want to change that, you need to click on the Insert Pins on Equator line. And it's going to open up all these other options for you. We have material options, we have object type options, and you can interact with both of these. So if we clicked on here, all these options open up here. So if we wanted to change specifically for full contour crowns, we only want 2 sprues. Or only for zirconia, we want 2 sprues. Or we want, on full contour bridge work, a maximum of 4 sprues. All of those options can be set there. And right here is where you're going to set your number of supports. And you can also set a minimum number, too. Another topic has always been what kind of support pins or sprues to use with your objects. So you can set all of that for material or object types, and you can just do assign uncuttable, so that's the default with the blue sprues. Or you can have semi-cuttable, as well as you can disable some of the pin length and supports objects.
Yep.
Do you want to go on
Perfect.
offset?
Sure. So what we have here is we have a full arch case that's going to come in as a default 2.7. What we can see here is these are undercuts that we want to mill out. We want to get rid of as much of that purple as possible. And so what happens is if at the 2.7 millimeter part border offset, this is what we're left over. So when you do a residual simulation, this is going to tell you that in these areas here, you have about up to about 0.2 millimeters of residual material. It's still left that you're going to have to manually remove. Anything with yellow is probably up to about 0.5 millimeters of space. So what we can do is we can actually come here and we can change this part border offset from 2.7 to 5. 5 is just it's just an arbitrary number. You can try it at 4.5. You can try it at 5 is what I like to use. One thing to keep in mind is if you are going to change the part water offset to be a larger number, it is suggested to change the thickness of the sprue. So typically the sprue thickness is 2 millimeters, 2 millimeters at the stock and 2 millimeters at the part. I like to change it to 3 millimeters on both. And here we can see it's now at a part water value of 5 millimeters, which again is going to increase the space from the part to the stock to 5 millimeters. What this is going to do is it's going to open up more space, which will allow the tilting of the mill, allow more tilting of the mill to allow the tool to get into more of an undercut. And this is what we're left with. So you can see you have a much, much cleaner mill with only certain areas over here, much, much less post-processing work for your technicians. So when you compare these two like this is what you get. This is going to require not a lot of work, but your technicians have spent a lot of time to design this, only to have somebody go in and remove all of these areas to define them. This is coming out of the mill more or less exactly like it was designed. The other efficiency that we have found that is very important is the way that your system gets networked. Now, you can network your systems in a number of different ways, but typically what happens is you have your CAD PC, and when you're finished designing your crown and you've created your STL, you put it into a folder, and that folder is shortcut onto your CAM PC, right? And so the file lives on the CAD PC, and it's brought in into Mailbox via networking. The issue with that is that if your CAD PC is not on, or it is not working, or there is an issue with the networking, you can't access those files. And so what you end up having to do is putting your STLs onto a thumb drive and then transferring them over. So what I'm going to show you here is the way that I like to do, the way that I like to do my networking. Is this on? Yeah, okay. The way I like to do my networking is where I put the host file on the CAM PC, and then when I have created my STL on my CAD PC, I transfer it via networking onto my CAM PC, so it actually lives on the CAM PC. And then what I'm going to do is I go into onto my CAM PC, and I go into my C drive, and I create a file called Mailbox Files Do Not Delete. And within this folder, I put two more folders called Finished Milling and To Be Milled. And again, this is all on the CAM PC. Then on the CAD PC, I network that To Be Milled folder that lives on the CAM PC to be networked to the CAD PC. Once shared, I move this folder, I move the To Be Milled folder to the top of the quick access filter on Windows Explorer on the CAD PC. And this will allow for an easy transfer of the STL once it's been designed in your CAD. And this is what it's going to look like. So again, on the CAD PC, I'm going to have this To Be Milled folder, and this has actually been networked from the CAM PC. So this actually lives on the CAM PC. And so this is an example of what we would do on 3 shapes. So right now, I have created this STL. I'm just going to go through my advanced. I'm going to generate my CAM output. I'm going to go try find my STL and my PTS. And I'm going to just transfer them right to the To Be Milled folder. And now they still live on the CAD PC, but it's actually hosted on the CAM PC. And then when I go into my C drive and I look in my Do Not Delete, there are my files in my To Be Milled folder. Within Mailbox, I can actually just copy these 2 files over into this Explorer window over here, which is great because now I can just go right to my To Be Milled folder, and all of my STLs that need to be milled are in that folder. But we're going to do one more thing. We're going to go back into the configuration over here. And what we're going to do is right over here where it says save toolpath used, I'm going to click over here like this, and I'm going to point it towards my To Be Milled folder. And this is very important. The other thing that I'm going to do is I'm just going to go below it to the automatically move of imported files. I'm going to put that into the finished milling folder. And this is what's going to end up happening. start mailbox job as we normally do. We're going to open the job, find the mill, find the material, and it's automatically going to go to my to be milled folder. Automatically. It's networked that way. And the way that we've set it up with the finished milling is that once you have selected this material, selected this STL and the object type, it's automatically going to move that file into the finished milling folder. And the advantage of that is that if you need to remill this case the next day or the next week or the next month, you don't have to look for it on your CAD PC anymore. It's always just going to be living in your finished milling folder.
Good old abutment cylinders caps.
Right.
So this is probably one of the biggest hot topics, at least recently over the last couple of years, is how to handle those red caps that are coming in on your screw retain crowns and your screw retain bridge work. And a lot of this is customers that are deleting the red caps or thinking that they need to because of previous versions of software or other CAM softwares or CAD softwares out there. And the reason for that is we don't want to be doing this. This is causing more problems than most labs actually think. And what those caps are is when you're looking at a cross-section of one of your hybrid abutments here, your screw retain crowns, is it's going to block the top of your screw access holes. And it's going to do one here across the occlusal surface, and then if you were to flip one over, you'd see one inside as well. What that is doing is it's creating an invisible boundary to tell the CAM software of where it is going to use very specific tooling and when not to. So if you were to remove both of these, it would treat this as just a large hollow cavity and would probably end up breaking one of your 1mm tools. And then you'll call your support team and be very, very unhappy. So if we were to look here, and this is just on a transparency crown, we can see that it's marking the very top and very bottom of the upper screw channel. It's not going all the way down to the bottom because this is a different surface when the CAM software is inspecting it. It treats the upward-facing surface and the downward-facing surfaces as two different parts of the object, and that's important to understand. So when customers are doing it without the access hole, it's going to basically treat the entire operation using not drilling operations, but just using their normal finishing and normal roughing tools. When you leave the caps there, it's going to dictate the actual drilling hole operation, which is utilizes in Argen's mill box to use a 1mm flat tool to excavate that drill hole. So we can see here, if we're just going through the normal roughing and finishing stages, we can kind of see the outline of where the screw hole was, but it's blocked off here. And then later on in the simulation, we can see here what happens when the 1mm flat tool comes in to do the actual drilling operation. And what it does is a lot of customers will notice that they'll see the tool coming down and then bounce back up and then go back down and bounce back up. And what that's doing is actually to remove the debris from that screw channel. If we didn't have the red caps there, the 1mm tool would be just driving all the way down.
You can go to the next one.
Oh, okay.
We have a video.
There we go. This is the video. Sorry. So right here, we'll just see a short animation of what the system's going to be doing during our hole milling operations. So we can see it just slightly going down, and then it will pump back up.
Yeah, so basically what it's doing, it's treating this hybrid abutment almost as a full contour crown or as a crown or a coping. And then when the hole milling operation is enabled within the mono strategy, it then basically it basically removes those caps.
Yep. And that's that process there. Right. So when you don't do it, it's going to misinterpret that surface. And that's when you're going to have problems where could be milling from the bottom side or from the top side, but it won't be using that drilling operation. Sometimes customers will mill it and they'll never have problems, but 90% of the times we get calls with customers that have hybrid abutments, screw retain bridge work, and either the interfaces aren't milled correctly or the occlusal surface has got large gouge marks through it. 90% of the time it has to do with those red caps have been removed, or when it was brought in from the CAD software, that information wasn't brought in from the CAD software, and it didn't actually identify those areas. Is this a video?
Yeah. So this is we're just showing you the process of what you would be doing if you import a hybrid abutment and it does not recognize the surfaces properly, and just how to fix that.
Yep. So if it only came in with maybe the upper red cap or none of the red caps at all. So right here we can see one was put down at the interface surface, which is incorrect. And we can also see obviously a lot of internal surfaces there as well. So we come in here under the tools menu and then come down to curves and surfaces. And for this situation, since this has wrong curves, we'll click on delete. And then you can just manually click on the various curves or red cylinder caps to remove them completely. Once you've removed all the surfaces, then we can go back in and properly identify the various surfaces. And you do want to make sure you get every one of those little random erroneous curves, even those little green lines, which are the direction of the screw channels. So first thing we come in here is going to do cylinder detection. And you need to click on an internal surface that is as round as it can be. We know that the occlusal surface of some crowns has got a lot of geometry to it, but if you click on some place that you know is roughly going to be round, you'll then be able to get that nice insertion direction of the screw access channel. And then you just do the exact same thing when you click on identify cylinder. And then it will add the caps for you, but both the top and the bottom of the screw channel. It should not be placing one down at the interface.
Correct. And the reason why it looked like that was because we imported this hybrid abutment in as a full contour crown.
Right. So one of the new features that's going to be coming out in the next release of the Argen software and the Millbox software is this kind of intelligent detection. So if you were to accidentally bring in a screw retained unit as a full contour crown, the software is going to identify that and saying, hey, this crown actually has screw channels and implant positioning information. Did you really mean to bring it in as a full contour crown, or do you want us to bring it in as a hybrid abutment for you? So that's going to help reduce a lot of user errors in that respect. Another big question that we have is hybrid abutments versus anatomical abutment bridges. A lot of the misconception is that a hybrid abutment is just a single unit, and because this verbiage up here has bridge in it, or anatomic, it has to be full contour in multi-units. And that is incorrect. It has solely to do with internal geometry. For a hybrid abutment, you'll see here on the internal geometry, we have curved surfaces that are intended for tie base information. It usually has anti-rotational notches or grooves, but it has rounded internal geometry. The other option here, you'll see on this restoration, we have sharp 90-degree corners and flat surfaces here. This is the geometry that the software is expecting for anatomical abutment bridges, which is traditionally when you're cementing in those multi-implant cones, two connect parts, things like that. And the reason why this is important is because when we're milling these restorations, actually I'll probably go back. We're using different tooling for this kind of a geometry and different tooling for this kind of geometry. And if we have the incorrect object type, we're not going to get the internal fit that we're looking for. So hybrid abutment can be used on single units and bridges. They can have anatomical features or be a cutback or a frame. It is not limited to just single units. And it is for cavities that have rounded surfaces on internals. For the anatomical abutment bridges, it can be smaller units or large bridges, but it has to deal with this flat internal geometry that has the 90-degree shelf. And what it will do is it's going to use a drilling operation internally. So it's going to use a flat tool to go inside to refine these surfaces, which is not true for hybrid abutments. We're going to use rounded burrs because we have rounded features. So if we have rounded features, we use our rounded tooling. If we have flat features, we'll use our flat tooling, and that's important. So here we have a sample of an anatomical abutment bridge. So we've got some conical inserts that would normally go in here. And when it comes in, you'll notice that when it comes as an anatomical abutment bridge, we do have red caps on the bottom. And that's an important distinction. So if you have a hybrid abutment that comes in with red caps, that's wrong. If you have an anatomical abutment bridge with red caps, that's right. You'll also notice that here at the engaging interface, we have a tealish color being applied there. That's letting you know that there's actually an internal geometry that the software is going to be identifying and interacting with. So here we can see, we'll still get the red cylinder caps for the screw channels. Everything for that is still the same between hybrid abutment and anatomical bridge. It's really just this internal features that we're seeing. And with anatomical abutment bridges, we will have a variety of screw caps here because now we have a vertical surface that looks just like a screw channel, but this area we're going to refine with a drilling operation from the marginal aspect. So what would happen if you nested an anatomical abutment bridge as a hybrid abutment? Would it mill? Yeah. But if you ran a residual simulation of what your design looked like after it milled out or what it looked like here, you're going to see that there's residual material because we used a rounded burr to mill out an internal space that had flat features. Versus if we had it nested up as an anatomical abutment bridge, the correct object type, we're going to see, whoop, what happened there?
No, should be the next
there
one.
it goes. We can see that it machined that surface much more accurately. Contact avoidance. Hot new topic.
Yeah. So Millbox has the ability to visualize the contact areas that have been designed within your CAD, which will help with the efficiency when nesting. Okay, so this function requires that the contact data be output from the CAD system. So I can show you how you do this on 3Shape, and it can be done on all materials, but you're going to go into 3Shape and you're going to go into the manufacturing processes. And you're going to pick the material that you have. In this situation, it's a local mill Argen Z, but it can be on any material. And right over here, you're going to click Output Contact Areas. And what it's going to do is when you generate your STL, it's going to generate the STL of the STL of the crown. It's going to generate the PTS, which is the margin file, and it's going to generate one more PTS, which is called the contact area PTS. And so this is an example of actually what it will look like when you import it within Millbox. So it does not differentiate between occlusal contacts or gingival contacts or adjacent contacts. It just shows that that's where the contact area is. And so when I made this on purpose to be high, just to show. Now, what's going to happen is, as it stands right now, when the software puts the sprues on, if it puts the sprue and it's directly on this contact area PTS, it's going to glow yellow, and that's basically just telling you it's right on the contact. As it stands right now, if this sprue was to have been placed automatically in this area right on the contact, which is obviously a big no-no, it's not going to glow. It's not going to glow at this point right now, but what it does is it gives you, or the end user, the ability to see that this sprue is within the contact area and it needs to be avoided. So Millbox is currently working on a solution to avoid the contact area completely. And the sprue will glow yellow if it's placed directly onto that contact area curve. And realistically, it's just about bringing in 7, 8, 10 units and then being able to visually see that the contact has a sprue on it. There's nothing worse than taking all your units out the mill only to see that you have sprues all over those contacts. And like I said, Millbox is currently working on an algorithm to actually avoid that area completely. All right. So one of the big topics these days is denture milling. In the latest release of Millbox for Argen, which is anything 2019 and higher, we have developed a dedicated strategy for faster milling times, specifically for dentures and monoblock. Millbox for Argen has the option to use a 3mm toric tool, specifically designed to remove more material. And on average, compared to what we were using on a 2018 version, we've seen a 57% decrease in milling time without losing any sort of accuracy or precision. The other thing that we're seeing is Roland has what's called the TRK, the time reduction kit. I don't know if anybody has seen this or have used it, but basically what it is rather than purchasing a disc of PMMA, it's a silicone mold where you basically pour, you mix your own acrylic and you pour it into this mold, and then that fits into a clamp, which then fits into the adapter, and the whole idea is that you can mill your own denture base. And this is kind of what it looks like. So I've just nested this with 4 large sprues, but it's putting it into, this is what the block of acrylic would look like. It's something that you would mix and pour yourself. So when we talk about the advantages and the disadvantages, with the denture disc, you can use an Argen DS or alternative PMMA disc that's been pressed. We are seeing much faster milling times with that. The strategy has been made by Argen. Nico was the one that worked on that very hard for us to get those reduction in time. It uses our current Argen tooling, so you do not have to change your tooling. It's going to use the current HP or the Argen Hybrid Plus tooling, and it gives you the ability to use that 3mm Torque tool. That 3mm Torque tool is very important because it comes in and it just removes a lot of material very, very quickly. If you're going to use the Roland TRK, you pour your own acrylic into the mold. There are slower milling times. The strategy is directly from Sim Systems. Argen has nothing to do with that strategy. You have to use specific tooling from Roland, and as it stands right now, there is no option to use that 3mm tool to evacuate all of that material. And so when we take the same denture base, what we're seeing here is we're able to mill this in 169 minutes. This is using our new and improved Millbox for Argen denture strategies. And if we're doing the TRK, it's 285 minutes. So there's a huge time difference with that. I also feel like you will get a better quality prosthesis with a pressed PMMA disc.
So some of the new features that are coming out in Millbox, late last year they released what they called the Roland Standard Edition, which encompassed a lot of features from some add-on modules that Millbox had previously released. And so they released 2 add-on modules a long time ago, and it was called either the Comfort add-on or Expert add-on. And each one kind of had some certain bells and whistles that went with each one. In, I think, August of 2019, they merged the Comfort add-on module into the Roland Edition. And one of the big, I guess, benefits of it is now you can do multi-import STLs. In older versions of Millbox, you had to navigate to individual files and load them one at a time. Now, if you're using a network setup where you have all your STLs in a single location, you can just highlight all the object types, or all the STLs that match the object types that you're looking for, hit the plus button, and it's going to bring them all in a queued format, and you'll just see an update as they go through here. So that is one big speed increase. You're not manually having to search for all of your designs. Another thing that they have changed in there is what they call the search filters feature. So basically, currently in older versions of Millbox, you weren't able to search for the STLs you were looking for. So if you knew the order number or the patient number or name that you were looking for, you'd have to scroll through the list of files before you can go in there. Now you can just type in here in the file format, and you can see here I have a list of STLs. I started typing FCB, and it just eliminates the entire list. It just only shows you the object types that you're searching for. This works not only with STL imports, but also job files. So if you specifically name your files a certain way, and you want to go back and search for a job that you milled yesterday, last week, a month ago, same thing. You can go to Open Jobs, start typing out the name that you're looking for, and it will dynamically search the fields for you to reduce any time you need. So you can see there. Another change in the recent software is, one, they've integrated webcam integration. So in the advanced features, at the very bottom in the general pat, there's an area to add a webcam. A lot of labs want to see what their mills are doing, but their mills are in a different room, behind a door. This way, they can just take a webcam and hook it up. It can either be on IP or locally just via USB connection. And you can set it up to be, I believe, in any of the 4 corners. I just left mine down here in the bottom right. And you can get a live look at what's going on with your mill while you're nesting. Another thing that's active now is the ability to reprioritize multiple Millbox windows. A lot of customers will start a job and then open up Millbox again and start calculating another job. Now, if you click on the start milling operation, it's going to prompt you with this. Do you want both versions of the software to have the same priority, so both working at the same pace, or is this a rush case? Do I want to prioritize this file that I'm nesting now to focus the computer's resources on that job? Another big topic is PCs. PCs have a lot more to do with your CAM setup than you probably think. And if you've got a system that's maybe a DBX50 from 2012, your PC is right now 8 years old. You are 2 times older than you really should be. The way hardware is changing nowadays, you should be swapping out your PC at the latest every 4 years if you want to make sure that you're getting the best out of your software. Every year the software is changing, and it's on the demands of the PCs that are coming out. So in 2012, your average specs was running Windows 7. As we know, that just got decommissioned. You had an i7, and it was 2.6 gigahertz. You had 8 gigs of RAM. You had a 2 gig video card. And you had an old 500 gig hard drive. In 2016, you might be running Windows 8. You might have an i5 at 3.5 gigahertz, 16 gigs of RAM, a little bit more video card, and you probably had a bigger hard drive. As of right now, this has the going specs on a really good CAM computer. We're at an i9, 5 gigahertz, 32 gigs of RAM, we have an 11 gig video card, and we've got a 500 gig solid state hard drive. What does that mean when it comes to milling? So this is your standard kind of PC nowadays when you buy them. If you were to increase it just a little bit. So right here we can see we went from a hard drive to a solid state, and we went to a better video card. Your calculation times are going to decrease by 10%. If you were to move to a PC with even more specs, so an i9 with the 32 gigs, solid state drive, and a better video card, 25% reduction. Who doesn't want to do 25% more work faster? Right here's an example of kind of what your standard PC import times are going to be in calculation times. So if I'm nesting up a full disk, to bring in all of those files, probably took me 3 minutes, and it's going to take me 20 to 25, maybe 30 minutes to calculate. Doing a big all-on-4 case, probably took me 1 to 2 minutes to bring it in, maybe 20 minutes, 30 minutes to calculate it. So you can see here what a standard kind of average PC is doing for your full contour, and this is for import times, how long it takes to bring in those STL data and get it inside the system. So we're taking minutes off of every job. And that's just for a single full contour bridge or just a mixed full disk. On calculation times, we can see here with a standard PC of what it would take to calculate a full contour bridge, full arch bridge, half an hour, down to 23 minutes on a better PC. And that's just using kind of the simple workflows. So that's maybe 3+2 indexed, no external undercut milling. Maybe we're not even using the 0.3, we're just using the 0.6 internally, no brush tool. If we wanted to do the same kind of work using maybe a 5-axis continuous strategy or do some other detail milling, we can see here the times jump. So mixed disk at 20 minutes went to 34. This went from 16 to 27. We're seeing here a change in about anywhere from about 5 to 10 minutes in decreased calculation times or import times for your systems. So you should definitely be making sure you're staying on top of your CAM PCs. Some of the changes that Argen's been making within Millbox, and a lot of these features are only on the 2019 or newer features, is we've done some work to decrease the clutter on the interface. It's kind of sensory overload with some of the options there. We've also brought in a new object type for the overstructures. We've modified the denture milling and the 90-degree milling change. One of the topics we will be talking about is the fact that you can do 90-degree milling on the 51D. A lot of people either don't know it or don't know how to use it correctly. And now it also has the prompts for the new software to let you know when you brought in something and it needs a screw access hold on it. So 90-degree milling. Do you want to talk?
Sure.
There we go. We'll do some 90-degree milling.
Surprisingly, there are a lot of customers who have the Roland 51D who do not take advantage of the 90-degree milling. The 51D has a C-clamp And if set up properly, you can actually have the clamp go 90 degrees, and you can actually mill the facial, the buccal surfaces without any sort of interference of the outside of the disc. The problem is in previous versions, there were a number of steps that you had to follow, and if you didn't follow all of those steps, it looked like you were going to be able to mill it in 90 degrees, but it just never took place. So we now have a much more streamlined process for the 90-degree milling on the 51D, which is what will happen is when you bring the unit in, you're going to click this button over here like this, and it's going to ask you, do you want to select parts to be milled on the open side? And it's automatically going to take you to this field over here. And this field here is now going to allow you to paint the areas that you want milled on the 90-degree milling. And so this is what it's going to look like. So as we stand over here, we're going to move this out. So yeah, go ahead. Yep. So we're going to move the unit out until it goes yellow, which means it's cutting into this portion here. But again, there's no boundary from the C clamp. You're going to click that button, and it's going to open up the offset areas over here like this. And as soon as you click this, it's going to say, do you want to select the parts to be milled? And you're going to click yes, and it automatically opens up over here. And now you can just come in and you can actually mark the areas that you want milled within 90 degrees. So it's going to keep on working on this job, and then when it gets to this portion of the operation, the disc is going to be like this, and it's going to pop up 90 degrees, and the areas that I've marked over here, it'll actually go in and mill like that. So what ends up happening is when you're starting to do anterior work, and your designers put in a lot of time to make sure that the proper texturing and contouring is there, and then what ends up happening? You end up putting a bunch of sprues on there. So if you do have the 51D, this is an option for you to keep the actual design from being covered by sprues. Can you talk about the updater?
Yeah. So another big topic is always about when to update, how can I update? The process can be somewhat cumbersome sometimes. So one thing that Argen's done now, and this is going to be in one of our future releases here, is we're actually going to include an update button. So we'll manage when the updates are pushed out, and we'll mark it and let you know, hey, you can go ahead and upgrade. And you'll just click that little button, and it's going to take you directly to a link to where you can then upgrade your software so that you can do it on either your time or know that you're getting the most recent versions. This is more of a kind of a public service announcement. So who here has a 52D or a DCI? You got a couple? All right. How many of you have had bad parting lines? That's the offset between the top of your object and your bottom object. How many of you had service visits? No? All right. So reach out to your resellers, whoever that might be, and you're going to get these 3 parts. All new mills as of maybe about a month or 2 ago already have this little cylinder on their calibration object. If you don't have this, this will correct about 95% of the parting line issues along the X and Y axes of your systems. Just tell the service, tell your provider, hey, I'm having parting line issues or sporadic parting line issues. Can you get me these 3 parts? They'll put in a service order to Roland. It'll get shipped, and it's just a matter of screwing and bolting this little cylinder in here. What it does is, as long as you're on the most recent firmware and vPanel for your mill, and this is only affecting the 52 series, so you need to be on the 3.4 vPanel, and you need to be on 1.41 or 1.8, I think it is, for the 52 or 52 DCI systems. And that's all you need, is those 2 parts. You put it in, you run your normal calibration, and during the process, it will look for this cylinder if you're on the 3.4 vPanel. If it doesn't find it, it goes through the normal calibration process. If it does touch it and find it, it goes through and it refines the X and Y movements more. So if you don't already have this part, reach out to your resellers and get it. It should help a lot of you with any parting line questions that you guys have on those machines. So thank you very, very much for your time. If any of you have any questions, feel free to come up. We're here.